I will be representing ASML. Of course, this is just one part. I represent one division of the company, so there's a much bigger team behind me as well. And the way that I made this presentation is I know not everyone is necessarily as far along into the implementation of DFMPro as we are. Some are still building business case. So I do want to kind of describe what we thought about several years ago about how to actually sell this to management, and then also to kind of tell you what's going really well, what's can improve on, and try to give you tips about how to actually make this a little bit more successful based off the learning that we've had over the last several years. Now, just a little bit of introduction about myself is I'm a team lead within the engineering infrastructure group within Wilton, Connecticut. So the engineering infrastructure group is really about anything to do with kind of software tools that support the engineers. One of this is we use for our PLM system, we use Siemens Team Center, and we also use Siemens NX for the CAD software. And part of my job is really to make sure that we have adequate support in Wilton. And then also, I am heavily involved with a lot of the global training efforts as well. So we do lead a lot of the training efforts, at least in Wilton, for the global. And I'm involved in pretty much anything in that infrastructure kind of world. The other thing I do is I work on anything that related to NX. So of course, DFM Pro is obviously one of them. Otherwise, I wouldn't be here. And over the last couple of years, we've been really trying to focus on improving the usability of the software, reducing errors, improving training, because at the end of the day, we want the utilization to increase. And utilization doesn't only mean somebody hit the button, but it really means that somebody read the results, improve their design, and that can be quite the challenge. And I'll get into that more. Just kind of my experience. I do come with a background of quite a bit of different various manufacturing ability or experience. Now, I've been in this role for around 3 years, but before that, for quite a few years, I was a designer, lead designer, team lead for design projects that in the mechanical engineering group. And a lot of the stuff I did was mechatronics. So I did tiny little mechatronics, big mechatronics. But I've also have previous experience. I was working with high temperature, aero engine applications and extremely high volume powder metal applications for automotive industry. So it's been interesting because I've been able to work on machines that you build a few a year, and then also I've been working on powder metal parts where you build thousands a week. So I also have some hands-on experience of actually building Formula C race cars and MIG-TIG and stick welding and CNC milling parts and launching carbide cutters into the atmosphere, and not saying professional, but it does give me a bit of a background in manufacturing. Now, ASML itself is a company that you've probably never heard of, which is really it's really behind the scenes. All of the global manufacturers of chips around the world do actually use our products. And lithography uses light to basically print tiny little features on silicon. And I'll get into that a little bit more just so you can understand kind of the unique challenges that we have. And speaking of those challenges, these machines are extremely precise. There's really a high focus on motion control and metrology because we're putting features on wafers in the single digit nanometers. So you have to measure things to picometers or much better than what you're actually imaging. There's a lot of precision mechanics. So I'll talk about compliant mechanisms. So we use flexures. And this all ties into optical systems and software that's very complex. But at the end of the day, what it means is we have very low volume components, and a big focus of ours is really about performance of the actual product. So we're worried about quality. We're worried about making sure it's delivered on time. These are common themes, which we just heard about this last half an hour. And price really isn't the most important thing for many of the parts. It is for some. But we really want to make sure the quality is there and there's a good, robust design that can be delivered. Now, ASML has been around a while. my division in Wilton, Connecticut actually goes back quite a bit farther forward, and we actually has a history of working for Perkin-Elmer with well before my time with things like the Hubble Space Telescope, and later it was Silicon Valley Group, and now it's part of ASML. And ASML, as of last year, is 28,000 people globally. We have 1,600, and I think it's actually closer to 1,800 people in Wilton now. And our user base for NX is 3,000 globally and 700 in Wilton. Now, these are some of these people view, I would say maybe roughly a third of the people here in this list is actually people who create new product designs. And of those third, maybe 1,000 globally, we do have about 470 licenses of DFMPro. So they are in high demand, and we do have to kind of share them. We do have a very diverse culture as well, 120 nationalities in 6 countries. And this is kind of important because if you're trying to teach people from around the world of different cultures all the same standards, it becomes very difficult to actually just put this in writing and make sure it's something that's easily translatable to all the different cultures and languages. That's where DFN Pro is kind of a really handy tool, because you basically put all this information into a button, and it kind of just spits out a result. So a little bit more on the locations. The company is based in Veldhoven in the Netherlands. So that is really where the bulk of the design is done. Wilton in Connecticut is maybe 20% of the machine. Of course, that's where I'm from. And then San Diego is also a major, they have a very specific technology that they contribute to the machine as well. Those are the 3 primary sites that share the DFMPro licenses. We do have other sites around the world, but those are more from the support side. And just a little bit about semiconductor in general, the industry is enormous. And it's something that I really didn't appreciate until I started working in the company. Is that even in 2018, there were 600 billion integrated circuits produced. And this number keeps growing because as we go, there's more things like solid state hard drives and self-driving cars. These are really technologies that are pushing more and more semiconductors to be needed. So one of the things we like to say is that the computer or laptop or tablet that you're watching this presentation on is almost guaranteed to have an ASML produced chip or a chip produced on one of our machines. I know definitely the system that I'm presenting it on uses the technology that we have to actually, get this message to you. And semiconductor in general, just so you have a little bit of a frame of reference, people quite often see the silicon wafer and you have chips on it. But lithography is really at the center of this process. You start with a blank wafer, you deposit some material on it, you do a photoresist. And what we do is, if you think about black and white photography, you had a negative and you shine light through it, and we focus the light. We call that negative a reticle, and we use ultraviolet light. And you put an image onto a wafer. It reacts with this photoresist, and there's a whole bunch of developing processes afterwards, but you actually end up with a physical structure on a chip, or that makes up a chip. And these chips are 30, 60, 90, maybe even more layers, but it's really our machine is right at the center of the process. It's the most expensive part of it. And we're trying to put nanometer features on these wafers. So we do have a lot of cleanliness issues, and we have to be very precise. And that's where the more we can think about in our design about making things, say, easy to assemble, it just helps the whole process. Now, getting into the actual meat of the presentation here, how do we actually integrate DFM Pro into our system? Like we use Siemens NX, and part of NX is Checkmate. This is used to create rules to basically say you have to run DFM Pro before you can release a part to production. And I know other software out there has similar types of programs, so it's something worth checking in. Everyone has something comparable. Now, one key thing here is that we mandate that DFM Pro is ran but we don't actually mandate electronically that the issues are solved. So this is one of the challenges that we do have. And anything you can do electronically, try to incorporate that. And the other thing that we have is at least 850 users over the last 3 months have tried to pull a license at one point in time. So we do actually have to share. It's quite a big user base for the 300 or 470 license we have. And our checks are really based off of two things. One is the industry best practices, which really are best practices are really the out of the box DFMPro functionality. And then we also have ASML design rules, which apply to very specific use cases, or maybe we configure some of the out of the box checkers for our practices. And I'll say we focus on mono parts right now, not so much assemblies. There's some, but that's roughly 25% of the total new parts that we currently have. So common issues. The kind of issues that we currently have is this is really things that should be kind of universal to many companies. We do have some sheet metal, not too much, but interference with a flat pattern, part cut out close to an edge. These are things that DFMPro are quite good at catching and pretty universal. My personal experience a lot is more of the mechanical monolithic designs for machining, and this low volume or low wall thickness. And one of the issues that we do have is because we do have very tiny parts and very small, large parts in the same assembly. It's very hard to necessarily get good corner radiuses. So these ones come up a lot, small slots. We also have some unique types of things that occasionally we actually do want small fillets, even though we flag that we don't company standards. There's some conflicting things there because we have to keep things clean. Drill breakout section. This is actually a huge one because a lot of our technology now uses vacuum systems. And if you have this little tiny pinhole in the bottom of the thread, it could actually create a leak and something that's very hard to actually detect. So, it's an interesting use case that we can actually benefit from. Now, the summary of the use case kind of benefit is really this is minutes. You can have hours and hours of checks and you can complete it in minutes because what you're doing is you're consolidating knowledge. And at the time, we had 35 documents to find different various standards. And if you have a new hire come in, especially somebody with very little engineering experience, do you take 35 documents, print it, put it on their desk, and make them try to remember it? You can try that, but it's going to fail. It's very hard to absorb that much information and also remember where the information is stored later. So by putting it into DFMPro and having a button, you can take all this knowledge, you can take the lessons learned that you have over time and make it a button click. And we do this for things like water connections, is we do have an assembly check, one of the few that basically looks to make sure that you have the correct connection of parts. So the system is always kind of right the very first time, which, this is always the goal, first time right. And it's something that's very hard to achieve. So how can we get closer to that? And I already mentioned this is a learning tool. My personal view is DFMPro is a great tool to have, say, inexperienced engineers come in and start learning these different types of things that they should design and think about. And then as you develop in your career and you start making less and less errors in DFMPro, you're actually learning these fundamental things in the background. And then you can use it more for validation instead of learning over time. And of course, the end goal is reducing the number of conversations with your lead designers, with your suppliers, and a kind of a cornerstone for me is focusing on letting designers focus on the complicated parts and not necessarily the very simple, easy to define things, which I'm going to actually talk about in a minute. So what's easy to check with DFMPro? And this is well, let's just say catching easy to overlook, difficult to spot details with well-defined rules. Now, the engineering infrastructure team in Wilton, we have this mission statement, which essentially we're saying we're trying to provide processes and tools to let engineers focus on engineering. And if I look at this part on the right, this was almost a meter housing, and it has this 100 millimeter bore and bearing in the center. And this was done before we had DFMPro. And the the issue that we had with this part is that there's threaded holes which are very close to a bearing board and aluminum part. And what happened is when the manufacturer was threading the part, it actually deformed the bore, and we can't get the bearing in. So this is something that we solved with the supplier through process. We were able to thread the part first, and then we, instead of interpolating a bore, we turned the bore. So the issue went away, but with a very simple rule of saying don't put a hole this close to a bore, you're able to prevent this completely. So we're able to, with one quick check, we're able to avoid basically a 2 or 3 month kind of optimization of the process. And the other thing to keep in mind is because this was a very large, for us, this was a large frame, and you're looking at a tiny little M4 M5 bolts, unless you really have a lot of experience and a good sense of scale on looking at a computer screen versus on paper, or maybe you print one to one on a plotter, it's very hard to really kind of get a good sense of scale. And these things are very easy to miss, but it's also very easy to catch with DFMPro. And another really kind of important thing about DFMPro is that because we use this checkmate enforcement, we're able to actually 100% get DFX kind of investigation on parts. And one of the important things about this is when you're talking about design reviews, you tend to focus on the critical things. And most of the parts are actually relatively simple brackets that you might not look at. So we use this tool to basically cover those things and make sure we don't miss anything in the background. And of course, providing feedback to low experienced designers before they have a discussion with our lead engineers or suppliers. We, especially in 2020, there's been a lot of difficulty at least having face-to-face kind of conversations. So the more efficient you can make these conversations with your experienced people at critical times, it helps. So take all the easy stuff out, and I'll say that, like, if I'm looking at a part and somebody puts a radius in the wrong position, so you end up having a 4-axis feature instead of a 3, it's very actually hard for me to review the part, objectively. So get all of that stuff out of the way first. And of course, this is really great for well-defined rules. Now, the challenge is that design for manufacturability is definitely subjective, and it's very dependent on the part and the actual application. And we at ASML, we definitely have a lot of cases where designers say, I don't trust your tool because it told me there's 10 different ways that I can't make this part, but I'm holding it in my hand and it works. So your software isn't working. But what happens is a lot of this is based off of the company standards, and people are blaming the software tool instead of blaming the core standards that are behind the software tool, or at least understanding that there is a gray area here. And what we kind of do at ASML, at least especially in Wilton, is I want to use DFMPro as really, it's a discussion, it's a starting point to have these discussions. It's not a black and white tool. It's not the end all be all. You don't have to 100% fix every single error. What you need to do is make sure that there is some framework that you take this information and you put it into a discussion and a review process. So we actually integrate this into our design reviews now. At least we're working on it. It's a manual process, but I'll talk about that a little bit more. And one of the biggest things you can do is constantly remind your users where the help files are and to read the warnings. Every single opportunity I get to tell people, I do, because what I find is we had at least one situation that didn't understand why it was giving an error, but they never actually read the message. And you could tell that by reading, hey, this is an 850 millimeter depth of cut, where the designer thought it was a 40. the software was actually assuming that you were machining the part from the opposite side of what the designer thought. And this is because there was an overhang in the part. And they spent a couple days looking at this error, and then they finally, I told them read the message, and they finally understood. The other thing is read the help files. There's nice simple diagrams in there that show you this is exactly what it's checking. And for whatever reasons, users just don't like hitting the help button or actually reading the error. They just read the description. So keep that in mind. Make sure it's part of your training. And then the other big thing is I do like to focus on the positives of the software. So once again, this is the well-defined features, and this really does cover a majority of our parts, and it also covers a majority of the features of our parts. So on the right side, I show a little flexure that I designed several years ago. We do have these tiny little blades that are wire EDM'd in. They might be a half a millimeter or a third of a millimeter thick. And like I said, design reviews, you're going to focus on those blades. But DFMPro still can help you remember to give spacing to threads and do the other parts. 3/4 of the features on this part, on this model, still apply to DFMPro, even if we're not currently focused on the EDM as far as in DFMPro. And the other thing is the flexures themselves. We know that the senior designers and the people in the design review really will focus on this, on those features. Don't forget the other things. So other pitfalls, I wanted to include this just to kind of cover the types of issues that we're seeing and challenges that you might run into. And the first one should just sound completely obvious, that DFM Pro is only useful if you actually run it and you investigate the results. So, but DFM Pro is not implementing it. Implementing it means you have to make people run it, and you also have to actually have some sort of process to review the results. So making people run is easy. We use DFMPro, it's tracked electronically. But this is where I was starting to talk about what we do is we integrate it into the design review template in Wilton, and this is something that we will push and discuss in, say, the global setting as well, but we're still kind of working towards this. You have, in our template, you basically have to say that I reviewed my design with the senior designer and they agree that this part is manufacturable. It brings this conversation right to the forefront. Somebody has to basically promise that, yes, I did the work and I didn't just hit the button because I had to. And the other kind of thing is that for some reason in Wilton, there's a mentality that design intent and modeling for design intent is related to DFM Pro, and it really isn't. DFM Pro only looks at the final geometry. It doesn't know how you modeled the part, and it also doesn't need to. So keep in mind, still teach your users good practices, making sure that features and dimensions kind of align, so they're built well, design intent. And at the end of the day, DFM Pro is really about giving the designers a tool to make their job a little bit easier. It's not actually replacing them. So you still have to put a lot of thought into it. Just something to think about and make sure that your training and usage of this software makes sense. Now, one of the biggest challenges that we have is making sure we understand, was this worth it? If management goes and asks you, how much money did you save? I really can't answer that because you could have a part that has an error, know, catches it, easy to find, but I have no way of guessing if the lead designer would have caught it eventually or the supplier would have caught it. You might not save anything because all the other processes work. So it's really hard to actually put a dollar amount. So we do try to focus more on the utilization side. So ASML, I said roughly 25% of our parts run DFM Pro. In the last few months, we've been averaging 2,500 parts every single month, 2,500 new mono parts, and all of those have to have DFM Pro ran. So if you, even if you you save dollars per part, it really adds up, but it's really hard to quantify that number. So focus on utilization. How many designers are using it? How many parts are being run? Things that we are looking at is we do want to try to improve our data collection for errors. And one of the steps here is that DFMPro has this really nice report with Excel. You can disposition. You said, yes, I'm going to ignore this error. Here's the picture. Here's why. Here's who approved it. But these are actually really hard to currently grab, because if you're using NX and Team Center together, you'll know that the the Excel is actually hidden in the name reference of the model. And we are looking at ways potentially of doing a batch file to extract these and give somebody a collection. But if you, we also plan on sending an IR to Siemens to kind of help HCL give us the tools to do this more automatically and choose where to actually save this data. And then the other thing that we're talking about is maybe we can start collecting accepted versus rejected errors type of data. But currently this is all quite manual work. And the other thing is, if the designer uses the tool early, you actually won't see those errors. And that's actually the intent, get rid of them early. So some of it's really hard to quantify. And I just wanted to kind of create this slide, just say, if you're struggling to quantify, there's a reason, because it is quite difficult to actually measure if this is working. Now, my last slide here is really my tips to kind of improve your application. The biggest one is you have to enforce the use of DFMPro. I highly recommend you do it electronically. Processes always leave room for error. So checkmate whatever is equivalent. And of course, it's once you have these results, make sure you actually use them. I know I probably sound like a broken record at this point, but because design for manufacturing is subjective, it's really hard to actually kind of automate. You have to let some errors go. So make it part of your review process, make it part of your standard conversation, and formalize this. And one of the biggest things over the last couple of years is we did ask users what's wrong with the software. And we identify what kind of errors you constantly see over and over again. And this is something we actually do create a report to see what errors are popping up the most, so we can maybe target these. Because if you see the same errors, actually maybe 50% of your errors, you know that checker is probably not quite right. So ask your users, find out what's wrong. Until you fix those issues, they're not going to trust the software. So of course, you have to investigate where the issue is actually coming from. And chances are, at least in our category, what we've been doing is it's either standards related or related to actually a bug fix of the checker. And of course, fix it. And it's obvious, but if your standard is out of date, you have to talk to the standards departments or competencies that are involved and really update them. There's a lot of discussions, even in my career, early on, there was a lot of, you have to have chamfers on the outside of a part, radius is on the inside, never radius on the outside. But as technology progressive, those conversations are no longer nearly as applicable as they were 10, 20 years ago. Additive manufacturing is also changing this as well. So you can't apply manufacturing rules to additive manufactured parts. You have to have correct standards for these. And of course, the biggest thing out here is, if you have a that you don't think is correctly, talk to HCL. We sent a number of parts to them over the last couple of years, and they agreed there was bugs. And in June 2020 release, there's like 4 major improvements. And these improvements and bugs actually rolled out to everyone, I believe. And in December 2020 release, there's another 4 that really were introduced. And I'm actually excited we're going to release this version, the DFMPro 8.0, next week at ASML. So we'll have these new improvements, and then also we will get the new interface, which is something I'm looking forward to, because I like the idea of driving it less black and white about as far as pass versus fail, which is I think a positive direction for the software.